Okay, today begins Module 4, which correlates to Chapter 4 of the book. We'll be looking at increment and decrement operators, the different types of loops available to us in Java. We'll see how we can calculate totals using sentinel values and loops. We'll look at nested loops, the break and continue statements, how to decide which loop to use. We'll see how we can write to a file and read from a file using Java. And we'll look at random number generation. So first, we begin with increment and decrement operators. Now, take a look at these statements here. As you can see, they both have a single equal sign. However, remember that in computer science, these are not equations. What are they? Assignments. These are assignments, right? So the way these work, to review, is that we first evaluate what's on the right side of the equal sign. We take the answer from that evaluation and assign it to the variable which is on the left side of the equal sign. And all that we can ever have on the left side of an equal sign in programming is a single variable name and nothing more. So this first statement assigns number to be one more than itself. So in other words, it takes the current value, adds one to it, that becomes the new value of number. So if we came into this line and number, say, had the value of 6, then it would add 1 and the new value of number would be 7. This next line decrements number. So for example, if we came into this line and number was, say, 6, it would subtract 1 and the new value of number would become 5. We have shorthand ways of accomplishing the same thing. These are called unary operators. We have the increment operator, which is 2 plus signs, and the decrement operator, which is 2 minus signs. And we also have 2 variations of each of these operators. We have the postfix version, which is this version that has the 2 plus signs immediately after the variable. Then we have the prefix version, which has the 2 plus signs or minus signs immediately before the variable. So this statement, number plus plus, is logically equivalent to this statement above, number equals number plus 1. They accomplish the same thing. As a side note, has anyone heard of the language C and the language C++? You ever wonder why there's no language C+? Well, this is why. They borrowed the name of the language from this unary operator, plus plus. So it's supposed to be the next version of C. They call it C++. These operators are also available in the languages C and C++ and C# and many other languages as well. So let's take a look at an example, increment decrement.java. So here we have a variable called number, has an initial value of 4. Then we display the value right here, so number is 4. Then we say that we're going to increment the number, and this is the line that actually accomplishes the incrementation. This adds 1 to number. So when we get down to this line, it says now number is, what is the new value of number? Number was 4. It'll be 5. Thank you. So this will display now number is 5. Then we display a message, I will decrement the number. Here's the line that actually does the decrementation, or the decrementing. And we display now the number is, and what will number be at this point? Interesting. Let's take a vote. I heard 2 answers. So I'm recording. All right, let me bring up Paint or something. So how many people think number will be 4? Oops, 4 versus the other option that I heard is 3. So again, remember that this is not a democracy. Everyone must vote. Okay? So nice and high, who thinks number at the end of the program will be 4? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 votes for 4. And who thinks it will be 3? Raise your hand nice and high. 1, 2, 3, 4. 4 votes for 3. Okay, let's run the program and find out. The correct answer is 4. Who can explain why? That's correct. That's correct. So remember that variables can constantly have their values overwritten. So when we started, number was 4. We incremented, number became 5. And then from there, we decremented, which put number back to 4 again. Okay, so there was no, we do not decrement back based on a previous value. We decrement based on the current value. Okay. Questions on that? Now, there are differences between the prefix and postfix operators. In most applications, that difference will not have any impact, but there are applications in which it does have an impact, and you will develop an understanding of this when you attack the Module 4 math exercise worksheet. So prefix notation, again, prefix and postfix affects the variable in question in the same way, but prefix notation indicates that the variable will be incremented or decremented prior to the rest of the equation being evaluated, while postfix notation indicates that the variable will be incremented or decremented after the rest of the equation has been evaluated. Okay, so big difference in terms of the order of operations. So the rest, if these are part of a larger equation, then choosing prefix or postfix will have an impact. But in many cases, the difference is negligible. In this example, prefix.java, the difference happens to be negligible. Where'd it go? There it is, prefix.java. So this program is nearly identical to the one we just saw. The only difference is that the increment and decrement operators have the prefix style instead of the postfix style. So we'll go ahead and run that. And we'll see that the output is the same. So in this particular program, it didn't make a difference, but there are situations in which it will make a difference, and you'll see that in the math worksheet. That brings us to the first of the 3 types of while loops that we're going to learn about. Or, excuse me, the 3 types of loops, first of which being the while loop. The while loop is the simplest of the 3 types of loops. The syntax is as follows. We have the keyword while, then we have parentheses, and inside the parentheses we have a Boolean expression, also called a condition. And then we have a body of statements. If the condition is true, the body of statements will get executed. If the condition is false, the body of statements will not get executed. Furthermore, since this is a loop and not simply an if-then statement, these statements will continue to execute, looping, repeating, until the condition becomes false. Okay, so as long as the condition is true, the statements keep executing. And that's the basic idea of a loop. It's things that repeat. What are some other loops that you see in life, not necessarily in programming? College is a loop? I hope not. I hope you eventually get out. Okay, so repeat taking credits until you have enough credits, and then you and then you can get out. Okay, that could be a while loop. Yeah. Okay. So yeah, basically anything that repeats. In another class, a student mentioned NASCAR. They drive around in a loop until they've until you crash or finish, right? Whichever comes first. Hunger pains. Oh, now you're gonna make me hungry. That's not even fair. Okay, but yes, so maybe your hunger pains will repeat until you eat that jelly donut. Okay. Um, so the while loop is a pre-test loop. What that means is we check the condition first before we execute the statements. So if the condition was false from the beginning, what do you think happens to these statements? They do not execute. So it's possible that a while loop will repeat 0 times. That can happen. Now, let's assume that the condition is true the first time in. Would you want that condition to remain true? How many people say yes, we want the condition to remain true? How many people say no, we do not want the condition to remain true? Okay, not everybody voted. Do I have to repeat the rules? Come on. How many people say yes, we want the condition to remain true? 1, 2 and a half? No halves. You're either all in or you're all out. So how many people say we do not want the condition to remain true? Everybody else. Okay. That is correct. We do not want this condition to remain true. If it did remain true, we would have what is known as an infinite loop. Infinite loops are bad. Okay? Basically, an infinite loop is a loop that will keep repeating the statements forever until either the computer breaks or the power goes out or something. It'll just keep running. And obviously, if you're using a piece of software, you do not want to be bogged down with an infinite loop. So, what that means is, for you, the programmer, when you use a while loop, you need to make sure that you have something within the body of statements that causes the condition to eventually become false. That is your job as the programmer. Okay? So you have to make sure that it eventually becomes false. Otherwise, you have an infinite loop. Let's take a look at an example of a while loop. So here we have a while loop. So we ask the question. So we start out with this variable called number. Excuse me. Signed to 1. Then we ask, is number less than or equal to 5? If that's true, oh, I commented this out. Let me put that back in. If that's true, then we display hello and then the value of number. So what would this display the first time? Louder? 1. Hello, 1. Right? Number is still 1. After that, then number gets incremented to 2. At which point we go back to the top of the while loop and check the condition again. So what is number at this point again? It's 2. Is that less than or equal to 5? Yes. So we repeat the steps again. We say hello, 2. Then number gets incremented again, and so on. At what point does the while loop stop? No. When number is 6, it will stop. Right. While number is less than or equal to 5. So if number is 5, this evaluates to true. It will display, it will run these statements one more time. It's not until number becomes 6 that this statement evaluates to false. Everybody follow that? So let's run it, see what we get. So there you can see it displayed hello 1, 2, 3, 4, 5, and then the last one is outside of the loop. Let me put it in a space there. And then that's all. Okay? What we just saw, though, is a really good example of a very common error known as the off by 1 error. Okay, if you want something to stop at 5 and it really stops at 6, or vice versa, those are the things that you have to be very careful about, right? If you those are where the most of the errors occur when it comes to loops is in the bounds, whether it repeats 5 times or 6 times, and that is determined by either using a less than or equal to sign, or just a less than sign, as an example. So yes, this repeats 5 times, and then we have one more print line that's outside of the loop. Now, this is clearly a loop that ends successfully. It's not an infinite loop. But let's try this. One little change. Change that little plus sign into a little minus sign. What's going to happen? Which is called a what? Yeah, it's a loop. Infinite loop. Right? Why is it infinite? Right. It starts at 1, which is less than or equal to 5. And then we just keep subtracting 1. So it's just going to count backwards. All those numbers are less than or equal to 5. So let's go ahead and run this. How you guys doing? So it's counting backwards. It might take longer than that. Now, here's a tricky question. This example is technically not infinite. It will eventually stop. Exactly. So this loop will stop when the value of number reaches the limit of what an integer can hold. Does anybody remember roughly what that range is? Yeah? Very good. you have more decimals of accuracy than I did. Yes, around 2 billion. So when this gets to what exactly is going to happen is when this gets to the lowest range of what an integer can hold, roughly negative 2 billion, it will actually flip over to the highest value that the integer can hold, which is roughly positive 2 billion. It's a little higher than that. At which point, this will finally evaluate to false, and the loop will stop. You want to wait and see? No. So instead of waiting for it, I'm going to modify the program to subtract a much bigger number. So there it goes. And it ended. So you see what happened there? I was counting backwards by a large number. And when it got to that magic number, the negative roughly 2.147 billion, it flipped over to positive roughly 2.14 billion, at which point the loop ends. Something else to point out is that the actual counting to negative 2 billion happens pretty quickly. Okay, it's displaying it to the screen that is slow. So if so you can see right now it's counting backwards, displaying it to the screen. If I took out that print line, so it's not displaying to the screen, but it's still going to count backwards. Watch how fast it takes. So I'm gonna click the mouse button on 3. 1, 2, 3. Done. So it counted to negative 2 billion in that time. That's how fast modern computers are. Yes, by ones. So again, the processing power is not really in the counting. It's in displaying it to the screen. That's what's slowing it down. So it actually finished counting a long time before I ended the program. It just couldn't keep up in terms of the display. Okay, so that's what's going on there. Here's what a while loop looks like in a flowchart. So we have the flow of logic that comes down into this decision diamond. If it's true, then we execute the statements and we go back and check to see if the Boolean expression is true again. And that keeps happening until the Boolean expression becomes false, at which point we move on to the next part of the program. Note that the way this is drawn, if we came to the Boolean expression and it was false the first time, it would just keep going down. It would not execute those statements. So this is another example of an infinite loop. This example, this is a true infinite loop. This truly will never end. Let's look at what's happening. So we have this variable x assigned to 20. While x is greater than 0, we display this message, x is greater than 0. And that's it. So then it goes back up and it says, while x is greater than 0. Guess what? It didn't change. It's still 20. So still greater than 0. So it'll just keep saying x is greater than 0. True infinite loop. We could fix that by simply putting this statement here that decrements the value of x. So now this will cause x to count backwards from 20. And once x reaches 0, the loop will end. So this just shows how easy it is to create an infinite loop. It's ridiculously easy. So you want to be very careful not to do it because it can have adverse effects, clearly. The block statements in loops work pretty much the same way they do in if statements. Okay, you have the curly brackets, you have a bunch of statements. Either they all get executed or none of them get executed. A common application of the while loop is to use it for input validation. So if you're trying to get some data from the user, but only certain values are acceptable for the problem that you have at hand, you could use a while loop to check to see if they entered data that is within the acceptable range. And if they did not enter data in the acceptable range, then you prompt them to enter the data again. So you've probably experienced something similar to this when you're trying to log into your Hudson Valley account or any account for that matter, right? If you type your password or username incorrectly, it'll ask you to retype it. Usually there's a limit though, 3 or 4 times, and then you're cut off and you have to go through some steps to reactivate your account. So let's look at soccerteams.java. So here we have a loop. Well, first, before we get to the loop, this keyword final, what does that do? Yes? Correct. Final makes it so that you cannot change the value of this quantity, which is called a constant, right? So it looks like a variable with the very important distinction that you cannot change its value. So it's a constant. So both of these are constant. Min players and max players are both constants. Then we have this dialog box where we ask the user to enter the number of players per team. We store that variable in team size. And then we check to see if the number they entered is within the acceptable range. So while team size is less than min players, and what does this mean? This 2 pipes? Logical OR, correct. So or, excuse me, team size is greater than max players. It's comparing what the user typed to min players first, and then to max players. So if it's true, meaning that it's outside of the range, then it prompts them right here to enter the number again. And then it stores it in the variable again. If this evaluates to false, that means that they entered an acceptable number, and it moves on to the next question. Let's go ahead and run this a couple times, make sure it works. Enter the number of players per team. Give me a number. 8 players. Number must be at least 9 and no more than 15. Enter the number of players. So it said that's outside the range. Try again. Give me another number. 10, and then enter the available number of players. 15. So there will be one team with 5 players left over. It's not a very exciting soccer game, but it works. What if we enter exactly 9? Ooh, some hesitation. So let's bring up our very fancy Microsoft Paint. So the question is, if we enter 9, will it prompt again, or will it continue? All right, so the question is, at this point in the program asks us to enter the number of players per team, and we enter 9. Will it ask us to enter the number again, or will it continue to the next part of the code? How many people, and again, everyone must vote, think it will prompt us again? 2. How many people think it will continue? 1, 2, 3, 4, 5, 6, 7, 8. Okay, not everybody voted. Not allowed. Blow up, third option. Okay. Blow up. All right, you have 3 options. Everyone must vote. So let me delete these. So how many people think it will prompt again? Again, everyone must vote. 1, 2, 3. It went down. Okay. How many people think it will continue? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Jeffrey, was that a vote? You got to raise your hand higher, man. You got to be all in. All in. 13. How many people think it will blow up? 2 votes for blow up. I don't know, but I'm going to stand back when I hit enter here. Just in case. Drum roll, please. Continue. Most of you got it right. Very good. Thankfully, did not blow up. So, why did it continue? Min players is 9, exactly. So if we enter 9, is team size less than min players? No. And it's not greater than max players, obviously. So this evaluates to false. So none of this gets executed, and it moves on to the next part of the program. Good? Questions? Look at a gadget. Let's see here. If I spell it right. So most of you are probably aware that this exists. Wireless charging is available on certain gadgets. The current standard is called QI, spelled QI. So this is an example of a wireless charging pad. Just basically looks like a flat surface that you plug into the wall. And then if you have a Qi-enabled device, and in my case, I have a Samsung Galaxy S5, I bought this wireless charging case, not case, back cover for it. And when I lay down my phone on one of these chargers, it starts charging without me having to plug it in. So this is available on many different devices now, not all devices, cell phones, tablets, laptops. It is available on most of those devices. But what just was announced today is that IKEA is going to be releasing a line of furniture with wireless charging built in. So here's some examples of what that's going to look like. I think the most interesting application is when it's built into a lamp, because the lamp already has to be plugged in. So we just put the phone on the wireless charging on the wireless charging pad or tablet or what have you, and it starts charging. So what do you think? What's that? Is it cool? Is it dumb? What? It's cool. Oh, that's a good point. If you're at your friend's house and you charging your phone on their lamp, you might forget it there. True. Yeah. Well, that would be annoying. You can tell if it's charging or not. The phone usually lights up or beeps. Okay, a prank, practical joke. Okay, you have a twisted sense of humor. Any thoughts? Would you buy it? SkyMall Magazine. SkyMall Magazine's going bankrupt. Or they did go bankrupt. Yeah. Uh-huh. Do you also want brain cancer? Because that's probably a side effect. Yeah. No. The wireless charging pad has a very short range. I'm talking like a quarter inch within the pad. Okay, Luke's talking about charge anywhere in the room. That might be bad for your health, possibly.
I mean, I guess it's helpful. My charging cords are built to die eventually. Like all charging cords I have, they just for some reason they just stop working after a couple months.
Yeah.
So that might be helpful if it doesn't stop working after a couple months. Doesn't they have any long cords to get tangled up and ripped and so on and so forth. So.
What about the myth that goes on with if you leave your phone on the charger, like it blows up the battery? No, I've done that before.
Shouldn't.
Old batteries used to have like it would retain if you started charging it before it died, it would retain like that as its 0%.
Yeah,
Like,
old batteries used to have a memory, but newer batteries don't have that. Modern batteries have a chip inside them to make sure they don't overcharge, unless you buy them from, China off of eBay. Then all bets are off. But if it's from a reputable source, they're supposed to have that chip inside them. So what I heard on the radio was it will add $20 to the cost of the furniture. So these lamps probably like $30. If you add the wireless charging, $50. I don't know. Is it worth it?
I wish it was a bigger spot.
Well, then you can get this one. It has 3 surfaces, it looks like. Is that big enough? I don't know how big it is either. It doesn't tell us. That could be 2 inches long. I don't know. All right. Back to loops. The next type of loop we're going to look at is the do-while loop. This is a post-test loop. So this means that the Boolean expression is evaluated after all of the statements are executed at least one time. So the do-while loop takes this form. We have the keyword do, then we have curly brackets, then we have one or more statements inside the curly brackets. Afterwards, we have the keyword while, and then the Boolean condition. So as you can see, the statements come before the word while and before the Boolean condition. So we repeat these statements until the condition becomes false. But also, since the statements are first, that means that the statements must get executed at least one time. So let's take a look at an example that uses that. Test average1.java. So here we have several variables. We display a message. This program calculates the average of 3 test scores. We prompt the user for score 1, score 2, and score 3. Then we calculate the average. Then we ask the user if they would like to continue. And if they, excuse me, if they choose yes, then it continues. So notice that this keyword do happened first before all this stuff. Then all these statements were inside of that statement block. Then we have the keyword while afterwards. So the value of repeat will determine if we repeat or not. Let's go ahead and run it. Just give me a couple of numbers.
37.
Thank you. Another one. Come on, wake up. 2. So there's the average, 18.666. Then it asks us if we want to repeat. So if I type just capital Y, clearly that repeats. What if I type the word yes? Interesting. So let's take a vote. Yeah, I'll bring it up in a minute. So the question is, if I type yes, will it repeat or move on or self-destruct? So everyone must vote. Let's look at the code again. I've got it queued up here. So we're at this point. Here's the code. I type yes. Does it repeat or move on? Let's take a vote. So again, everyone must vote. How many people say repeat? 1, 2, 3, 4, 5, 5. How many people say move on? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Anyone say self-destruct? Only 1 vote. Did you vote before? I didn't see your hand, man. What'd you vote for?
Left one.
Okay. Not everybody voted. Let's try it again. How many people say repeat? Nice and high. Raise your hand. 1, 2, 3. Come on, high. 4, 5. Okay, how many people say move on? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Self-destruct? 0. Okay, good. I feel safer now. So let's see. Drum roll, please. Repeat. The correct answer is repeat. Why?
Type in A, B, C, D, E, F, G.
First letter is Y.
So why did it repeat when I typed yes?
Can you try yes with like lowercase on Y? No, you don't just see it on Y.
Before we try a billion things, somebody answer the question. Why did it repeat?
Because the first letter is Y.
Tell me more.
It takes it's repeat is a char variable.
I was gonna say it's looking for a char, so the first letter is.
It doesn't matter how much you type in, it just takes the first user
So
input
it
and
takes
assigns that
one
as the
character.
variable.
You're on the right track? How do you know that?
Because repeat is declared as char variable. I know that's how the char variable works.
There's a little more to it. You're on the right track?
If it has 0 inside the parentheses.
Yes. 0 here. Remember this method, char at?
So it's looking for the first.
It only looks at the first character. Char at 0. So I could type repeats. It just looks at the first character. Everybody follow that? Repeats. Just looks at the first character. And it works for lowercase y too. Right? Question. The message tells us to enter Y for yes or N for no. Does it actually look for the word no? No, it doesn't. All it looks for is that first character to be either capital Y or lowercase y. If it is, it repeats, and if not, it moves on. All right, we're out of time. Thank you very much. Have a great day. Stay warm.